Hi, and thanks for joining this Twitch session today. My name is Olawale Oladihin. I'm the Worldwide Technical Lead for IoT, and I'm joined by...
Hi, I'm Tanmay Sen. I'm a product manager for Amazon FreeRTOS in the AWS Internet of Things organization in Seattle.
And we also have...
I'm Gennady Borisov, co-founder and president of Klika.
And my name is Andrew Mazur, and I'm CTO at Klika.
And so thanks for joining this session today. We have a really great deep dive into the edge, connectivity, and applications you can build with your hardware. So what I wanted to do is actually kick it off and hear more about what our partners are doing in an embedded space. So we're going to dive into Klika and all of the great things Klika is doing with their customers. Gennady, we chatted a little bit earlier, but it would be great to hear a little bit about Klika Tech and how you're kind of innovating in the embedded space.
Thank you, Wally. Actually, Klika, we focus on building IoT products. End-to-end products from hardware prototyping to firmware to software, cloud applications, and mobile applications based on Amazon's platform. And with our offices around the world, we see a lot of applications. We see applications in industrial, we see applications in consumer IoT, and thanks to Amazon's platform, we can build those applications with ease and use those applications to power truly amazing things.
Awesome. So it's exciting because you're getting to kind of work in all these different use cases and verticals. You mentioned kind of industrial and power and utilities. Could you dive into one of the examples you found kind of most interesting that you've had in your IoT applications with customers?
Yes, actually, thank you. One of our customers, a great company we work with in Germany named NKT, we built a drum tracking solution. You would never think about cable drums as connected devices, but being able to connect those devices to internet, being able to collect the information gives a lot of power to people who produce and ship those cable drums. They are able to collect very interesting information to know where those drums are, what happens to them, are they being knocked down, are they being dropped, is it raining, are they being shined on with the sun, and being able to optimize not only the supply chain, but being able to project and predict what happens to those cables. It's incredibly powerful.
Yeah, it's really interesting because we have this balance where as things get more and more connected, you're now able to then kind of take advantage of the data, drive insights, and actually business value. We always have this kind of saying where we basically say, what is the business value you're driving? There's an IoT part to it, of course, when we dive into connecting and hardware and embedded systems, but there's also this, well, what does a long tail look like? How do you then turn that into an application that allows you to do predictive maintenance, quality control, logistics, and monitoring? It'd be great to hear a little bit more as well about the technologies. So you mentioned a little bit of your use cases, but how has Amazon and AWS services helped you innovate on behalf of your customers, and how are you using them?
Right. In this particular case, Amazon powers, I would say, end-to-end the entire platform, from devices connected to cable drums, connected to a narrowband communication network, which is then connects and sends all the data to Amazon's platform. And that platform, as of today, enables the company to collect this information on 3 different continents. It's not just our imagination, it's an actual system being rolled out right now.
Awesome. And as we kind of talk about the AWS services, I normally like to draw this analogy where I basically say, you have the cloud, which, at AWS, we're all familiar with the cloud services, having EC2 and S3 and spinning up resources horizontally. Then you have the edge, where you can think of that as maybe more embedded Linux and edge servers and applications that you might run on a plant floor in an industrial. And then with Amazon, we've also started building services like Amazon FreeRTOS, where you can go to the edge of the edge. You can basically say, I have these more constrained hardware and requirements, and I need to understand kind of task and queuing and semaphores and all the things that go into making them run really efficiently. And so it's awesome because we do have Tanmay here today to kind of give us an idea of Amazon FreeRTOS and help us dive into some of the architectures and benefits and features and implementations.
Sure, thanks, Wally. So just to get the definition right, Amazon FreeRTOS is an operating system for microcontrollers, the edge devices that we talked about. These are devices that are very constrained. We are talking about kilobytes of RAM and memory and compute power. So this is an operating system for microcontrollers that lets these small, low-powered edge devices to easily program, deploy, securely connect to the cloud, and then manage using device management. So Amazon FreeRTOS is basically, it extends the FreeRTOS kernel, which is a most popular real-time operating system for microcontrollers, with security libraries, connectivity libraries, and over-the-air update feature using device management. And you can basically look at the connectivity libraries such as Wi-Fi and BLE that we have today in Amazon FreeRTOS, and cloud connectivity libraries such as MQTT, security libraries TLS and PKCS11, which is an open source standard, and the over-the-air update with the code signing feature that we already exist and pre-integrate with Amazon FreeRTOS.
So Tammy, just to dive in a little bit is more. So we have the FreeRTOS kernel that's been around for 15 years at this point,
That's right.
a little bit longer. So with Amazon FreeRTOS, what you're saying is that we basically kind of took the kernel and said, how can we extend these interfaces for things like connectivity, OTA, and functionality? So is that how all the pieces kind of fit together in terms of the layers?
That's right. For any user to design an IoT application, the user has to go through a tremendous amount of work in connecting the security libraries, porting to the interfaces, and using these connectivity libraries and developing their do-it-yourself feature for over-the-air updates, for example. This is a lot of work on users. So with Amazon FreeRTOS, we have tried to do is that we have tried to do all these integrations together into one single platform so that the end users concentrate and focus more on their business intelligence and the end application rather than building the undifferentiated heavy lifting of porting to these interfaces.
Awesome.
So Amazon FreeRTOS, as we know, it's an open source platform, and it's free and under the MIT license. So users can download source code and use it for any application, modify it, and they don't have any contracts or commitments with AWS. So they can come up with any application, use it as they see fit.
And Tanmoy, you mentioned edge of the edge devices, which are hardware restricted. Isn't Amazon FreeRTOS a very power efficient OS?
That's right. It starts right from the FreeRTOS kernel. So the FreeRTOS kernel has several tickless modes, for example, in which you can stop the clocks from going inside. So that is one of the power saving features. But also with Amazon FreeRTOS, what we have enabled is whatever microcontroller that we are using underneath, we can, with Amazon FreeRTOS, we can use the low power modes such as Wi-Fi management layer. It enables low power modes inside the FreeRTOS kernel as well as the microcontroller, so that low power applications can be designed seamlessly.
Excellent, thank you.
Awesome. And then when it comes to Amazon FreeRTOS, you're probably seeing just different use cases you're implementing or having your customers use the service to implement. Can you dive into some of those use cases and applications that are a great fit for Amazon FreeRTOS?
Absolutely. We are seeing interesting use cases from all across the board. Going back to what Amazon FreeRTOS is, Amazon FreeRTOS is an operating system for microcontrollers, and we see microcontrollers in all devices, the everyday devices that we see. Fitness trackers, automobiles, industrial automation, asset tracking, everywhere that you see sensors, microcontrollers, you can use Amazon FreeRTOS to securely connect and use other services from AWS. For example, let's dive in one of the use cases, building access systems. You can actually use microcontrollers and Amazon FreeRTOS to securely connect to the cloud, send data to the cloud, and the cloud can authenticate whether to let the delivery person into the apartment or not. In another use case, for example, smart meters. Smart meters can send usage data to the cloud and perform analytics, and even lets the end users do the same dashboarding and see the analytics on the usage of the meters. And for vehicles, we can send diagnostics, vehicle telemetry, and other data for vehicles down to the cloud and have convenient dashboardings to see how the vehicle is being used.
So with all those use cases, it would be great to dive into some of those individual components you mentioned. So we have the software bundle. We talked about OTA, but there's also this entire qualification program where you can actually use certain hardware that's qualified with Amazon FreeRTOS. You want to speak a little bit how that works as a service?
Absolutely. So Amazon FreeRTOS qualification is our effort to provide libraries and qualified hardware so that users can start right with their development boards. So the qualification program comes under the broader AWS device qualification program, in which the device can log into the device portal and see the qualified devices. And those devices we can get software down and get started right away with Amazon FreeRTOS source code and some convenient code examples. But behind the qualification is basically there are two aspects to it. One is our Amazon FreeRTOS qualification tests, in which we see that all the qualification and the interface and the porting that we have done, is it right? Is it working correctly? The tests are out in public in GitHub, so any end developer, or whether it's a partner or customer and on their production board, they can use it. To enable fast development and see if the qualification is working correctly, we have also a separate tool called AWS IoT Device Tester, which is basically an automation tool in which you can run all the tests seamlessly and very quickly, so that you can think of it as a CI/CD platform, working through the porting and seeing all the devices and the qualification, whether it works perfectly or not.
That's awesome, because I think the interesting thing too, especially as we start diving into the hardware a little bit later, is that you want to see like what are the things that are going to work underneath the hood. So like, how is connectivity going to work? How's OTA? How's security? So having this testing and then even a qualification program to basically allow customers or partners take their hardware through the process, validate it, and then have it available for people to essentially use as a prototype or starting point. This creates a really, really rich ecosystem.
That's right.
Cool. So I know we've talked a little bit about Amazon FreeRTOS, and I know at least for Klika, you've done a fair amount of customization and implementation with Amazon FreeRTOS. It would be great to just kind of dive into how you think about taking some of the things like the BLE beta branch that Tamara talked about, or OTA, and start to build those demos, prototypes, applications for your customers.
Yeah, Wally, you're right. So we constantly receive different requests from our clients to connect different devices to the edge. And those devices vary from a water leak sensor to a conveyor belt on the shop floor. So the variety is huge. And those devices, they can interact with each other, or they can be connected directly to the cloud. And they can be connected to different network types. And they also vary, for example, local area network, wide area network, or even body area network, the wearable devices that Tanmoy mentioned. And things are complicated here, and also there are a big amount of different architecture types for microcontrollers, and it's not an easy task to pick up proper hardware. And things are not so difficult with the firmware and software that should run on top of this hardware. And we rely on the AWS products because they bring us these additional libraries that bring out of the box connectivity to the cloud and connectivity between each other. So we can say that we use constantly green grass on the edge, and we use Amazon FreeRTOS on the edge of the edge. So we can connect devices between each other, and we can connect devices through, let's say, a device that plays a gateway role with green grass on the board.
Great. So Andrew, I know we have one of those demos actually right in front of us. So maybe we can dive into the demo and what you have running, because I think this is a place where you took Amazon FreeRTOS, you had the BLE beta branch, you said, let's extend it, let's implement something short range using FreeRTOS and Greengrass. So can you kind of talk through what's all these boards on the table and how they all blend together?
Of course. So let me start from the use case. First of all, we have like a remote control, and this device plays a role of remote control of a virtual 3D camera. And how it works. Actually, this board has an Amazon FreeRTOS inside. And as Wally mentioned, we used BLE beta branch. So all this functionality and abstraction layers that it brings with this repository. And when we click a button on this development board, we send information to the cloud over MQTT. So there is MQTT over the BLE. So then this data is being gathered by the gateway. On this gateway, we have a BLE router, and we also have a greengrass. Everything works in a snap because this gateway is powered by Ubuntu Core. Then the data is being processed implicitly on the edge inside of this Regatta 500 IoT gateway and is being sent to the cloud. On the cloud, we have fully serverless architecture. We have Lambda functions that interact when the data comes to the AWS IoT core. Data is being processed, and then with the WebSocket connection, it's being put to the internet. And with a single page web application, we can see that things are changing when we click on the button. So let me please demonstrate. So I will click on these buttons here. Yep. And let's go to my laptop, and I will demonstrate how it works. So here is the 3D camera and the panorama. I'm clicking on the left button, and we see that camera is turning left. Once again on the left, and let's see what's there on the right.
It's much sunnier there than it is here.
Yep, yep.
Andrew, and what kind of development board is this?
So actually, we are using Nordic NRF 52840, and it has a BLE chip on this development kit, and we used already available functionality in the beta branch. It's a luck that there is a project that compiles the source code, and we just need to plug in our board, make some adjustments, and everything worked out of the box.
And just to show the same board but without the panel, these are the buttons Andrew's talking about.
Yep. So once again, Amazon FreeRTOS has additional abstraction layer that brings a unified API for any chip and hardware vendor you would like to use. So it's really neat because we only concentrate on the implementation, only on our business logic, and we are not thinking of any hardware abstraction layers. So we do our main task to implement the business logic our customers want.
Awesome. And Andrew, maybe even just if we were to pull that architecture up again, like I'll get my screen up.
Okay.
You kind of have this end-to-end flow. So like on my laptop, you kind of can see the different components, but you have the Nordic board running. Then you also have, that's for just the Amazon FreeRTOS BLE portions.
Yep.
Then you have Greengrass running here, essentially on the router, correct? So
Yes.
this is your Greengrass implementation that is using BLE locally, but then Greengrass is basically a Linux daemon. If you're unfamiliar with it, it allows you to run a process on your own hardware, and that process has basically a subset of AWS IoT core services. So it has things like MQTT broker, security, it allows you to do Lambda functions at the edge. So you're able to do essentially all these additional benefits without being connected to the cloud. So that is our edge versus the edge of the edge, which is the Amazon FreeRTOS.
Yes, and when there is no connectivity, everything is being handled by the Greengrass. And when the connectivity is being up again, everything is synchronized with the cloud. So that's the core benefit from our perspective of using Greengrass on the edge.
Yeah, so you get that duality, right? You can essentially, if you're online, you have a great connection, you're in Wi-Fi in the studio, you're just going to send data just over the fence. And then in other cases where you have maybe intermittent connectivity or you just want to batch things locally, Greengrass can do that batching for you. Amazon FreeRTOS and Greengrass are communicating over the local network, and then when you have connectivity, it comes up, send a few packets over to the cloud, go offline again for however long you need to. And then if I go back into the architecture, just to understand how you pulled all these components together, once it gets into Greengrass, you go to AWS IoT Core, and you mentioned the backend being serverless. So I see you've got Lambda, API Gateway, S3, Incognito. So how did those pieces kind of help you build like the UI or the dashboard or the experience that your end customer sees?
Okay, so when we collect the data from the edge, we just send it to AWS IoT Core, and we have several rules that are being compliant when this kind of data is received at the AWS IoT Core. Then we have several Lambda functions that just process this data and pushes this data to a special WebSocket connection to which our single page applications connect, and those applications are stored in the S3 bucket, so like a single page web application.
Okay, so it's interesting. So how that ends up working is you've got your web application. Because we use MQTT for AWS IoT, you can do MQTT or MQTT over WebSockets. So for end users, consumers, mobile phones, they just go over MQTT WebSockets, can ingest and receive data in real time. And then your devices can use MQTT just for a little bit lightweight, or in this case, also BLE. So again, doing something local. So super interesting.
Yep.
And back a couple of steps to the Greengrass, what we talked about, intelligence on the edge. Greengrass truly powers that intelligence on the edge. As you said, Wally, if there is no long-range connectivity, decisions could be made by the Greengrass edge device, and then sent to the edge of the edge, to the endpoint device, and vice versa. So it ensures the control and command situation to truly deliver on the business case.
Well, it's interesting too because maybe we can dive into this component a little bit more. So we mentioned Amazon FreeRTOS, you're using the beta BLE branch. Greengrass today actually doesn't have like a BLE, mode, so to speak. It has, MQTT, OPC UA, some industrial protocols. So it's kind of interesting. How did you actually implement this BLE bridge with Greengrass, knowing that we only have a few that are native out of the box?
We spent some time here. We looked at the examples that Amazon provides. So there are two different repositories alongside with the BLE beta branch in Amazon FreeRTOS. They just have an examples of the SDK for iOS and for the Android, and some demo applications that connect to the devices that are powered by Amazon FreeRTOS and transfers this data to AWS IoT Core. And we did something similar. We implemented this snap that has a daemon inside, and it collects the data. We call it a BLE router. It collects the data from the Nordic NRF 52840 device that runs Amazon FreeRTOS. It collects MQTT packages over the BLE and then transfers it to Greengrass that runs locally. And then Greengrass does everything implicitly and sends data to AWS IoT Core.
Okay, so what you ended up doing is you basically have this process running separately. And that process is, doing the conversion from BLE to MQTT. That MQTT is still local. It's directly to Greengrass.
Yes.
And then from Greengrass, you can then send information from there to the cloud.
Yes. Yes.
And I know something that's interesting with Greengrass is you get a fair amount of flexibility. So, we talked about the fact that you can run this sidecar, but there are also customers that can just take a Lambda function with Greengrass and run it long-lived, and then do the conversion there. So they can just say, well, I want it to be exactly inside of Greengrass core. I want it to be a Lambda function. I have a cloud developer that's great at it. They can do that mode as well. So it kind of, you had a couple of options you could pick from.
Yes, and also the third option is Greengrass connectors.
Yeah.
Okay.
Yeah. So yeah, I think for people that aren't familiar with Greengrass connectors, think about that as, I'll bring up something on my screen so I can illustrate the points that we've kind of jumped around on. But on my screen, you can kind of get an idea of how you might deploy these applications when we think of microcontrollers and edge applications. And what you can see on the far left is what Andrew kind of described. He basically said, I've got a process, and that process runs as a thing in AWS IoT, but it's local. All that process does is take BLE packets, converts them to MQTT, and then forwards them to Greengrass. Again, this allows you to run that sidecar parallel process. If you look at the top right, you can also do something where Greengrass takes the Lambda function and embeds it inside of the deployment. And that Lambda function can have access to local resources and can run long-lived. So Lambda function stands up, it has your own code in it, and it basically says, I'm just gonna run over and over and over again. So I can listen to different ports, do things over serial or I2C, and pull data off, convert it, and then send it up to the cloud. And then the last option is something that we released at reInvent, which is something we call Greengrass connectors. And for Greengrass connectors, that's something where we have pre-built the configuration for you for specific protocols. So things like OPC UA or Modbus have a Greengrass connector, or if you want to get to other AWS services, you want to go to AWS IoT Analytics or Kinesis Firehose, a service where you just want to stream data, you can do that through the connector space. So you had all these options. It seems like just to do the implementation in a really seamless fashion, you pick the first one, the process and the Greengrass.
Yep. Because actually we had some examples from Amazon, and it was like a native way for us to follow.
Awesome. And so I think we've got like a really good handle on this demo. And what is really interesting, you kind of built it, you have the first version, but then we always have these interesting conversations with our customers where, the first version isn't necessarily your last version. Gennady, I know you've seen it as well, is that you think this hardware is immutable. I mean, of course, the peripherals could be immutable, but you probably have conversation with your customers about how can you continue to innovate even though your hardware has already been deployed and do these updates over time. Yeah.
Right. Well, I mean, no design, unfortunately, is perfect. I mean, we all want to add something to the device right after we ship the device. And in old days, and I have some gray hair to prove it, we would drive for hours.
You're not alone.
We lived through it. Drive for hours and then physically plug out the device, plug in the new one, disconnect, run wires, rewire it, go through pain and suffering of making sure that that device on the edge is always the most full-featured, the current device. Nowadays, luckily, we have OTA. We could update device over the air.
Mm-hmm.
And you're absolutely right. Some of the customers, it is one of their first questions. What if I ship the device? What can I do 30 days from the moment of shipment? What can I do 3 hours? How can I fix the bugs, of course, if there are any bugs, or how can I add functionality to that device?
Mm-hmm.
So this is where we come to the OTA, to potentially using narrowband IoT is one of the options, and to the second demo we have. So
awesome. So I mean, it's great to hear how you're seeing this use case with your customers. So customers are kind of telling you, hey, we need to do OTA and we need help with how to do that. And I know Tanmoy, with Amazon FreeRTOS, you've kind of thought about how can you make OTA easier through this kind of libraries and configurations you give customers. So how does that kind of work in some more detail?
Yeah, absolutely. So with Amazon FreeRTOS, I mean, if you're looking at the screen right now, so it's
I'll bring out my screen.
so it's basically the architecture of Amazon FreeRTOS. What we see here is the microcontroller, which is the hardware lying underneath. With the vendor supplied libraries, you can think of the drivers and the board support packages that the microcontroller supports. And we have defined convenient APIs and abstraction layers and management libraries on top that you see as MQTT agents, shadow libraries, device defender libraries. These are the different convenient APIs and the abstraction layers that we have defined, so that along with the FreeRTOS kernel, the users are defining the end application, which is the blue box on top. The application code doesn't have to write directly to the TLS, TCP, and all those libraries that are underneath in the Amazon FreeRTOS internal libraries that we have defined. Mm-hmm. So we have pushed everything together. We have seamlessly defined all the interfaces together, tied all those together, so that you don't have to think about anything else going to these libraries. You think about the uppermost layers. For example, if you want to communicate to the cloud, send a message to the cloud using MQTT, you just use the API that is defined by the MQTT agent, and it opens up a task in the FreeRTOS kernel. So that's how convenient it is. For Wi-Fi management library, it's exactly the same. If you want to use low power modes or you want to scan access points around the room, you just use the APIs that the abstraction layer defines and the management library defines. and you interface with the Wi-Fi stack from third-party or the microcontroller libraries too. So you don't have to think about anything of that stuff. Now shifting to OTA agent, the agent that you see on the right. So OTA agent is another logic and the library management library that we have implemented for Amazon FreeRTOS, and this seamlessly integrates with our cloud services, the OTA cloud services. So you can going into the details of how OTA is implemented. So there are two aspects to it. One is the user, and the second is the OTA agent on the device itself. So when the author updates a firmware, has a firmware to be updated on the device, he or she basically uploads it to Amazon S3 and schedules an update job. He or she can use the AWS IoT device management console to schedule the update job and select the number of things and the number of devices. It can be all the microcontroller devices in a particular building or a floor of a building. So once that's done, once the update has been done, the MQTT agent sends the broadcast the messages out to the devices that there is an update, there's a firmware update out there for you. And then after that, the OTA agent inside the Amazon FreeRTOS library takes over. It takes the update, splits into chunks, smaller chunks, MQTT chunks, and downloads it to a separate partition in Flash in the microcontroller itself. So these chunks come in sequentially or out of sequence. They get into a separate partition, but once that happens, the OTA agent checks for the whether the firmware is correct or not. So there's a separate feature called code signing, which the user can use to sign and upload the images. And when the images are downloaded down to the device, the OTA agent checks whether the signature is valid or not. It's basically to see if it's coming from a trusted source. So once that's done, we send a notification to a bootloader in the microcontroller itself. Bootloader checks for the hash in the device and does a self-test, a small dance run, to see if the images are fine. After every verification has been done on the device, the older image is deleted, and the new image, the microcontroller boots up from the new image, which is the new firmware. And the OT agent sends a notification to the cloud that the update has been done. So this is the mechanism of the entire OT framework that we have today. It's basically for customers. We provided a standardized interface and a mechanism to do over-the-air updates for remote devices.
Awesome. I know when we actually dive into the demo, what's interesting is with each one of these interfaces and libraries, because it's something where customers can customize how that OTA process actually works. For example, for Klika, you were able to do some of the things that Tamoy talked about, but then over BLE. So you're able to customize the OTA agent a little bit to use this BLE protocol, but then still take advantage of all the richness Tamoy mentioned about the code signing and the essentially dual partitions and booting off of the new binary. So Andrew, you want to kind of show how that works?
Yes,
now that we know the
and
theory?
Actually, I'll show how it works in real time. Everything that just mentioned Tanmoy is being run here on the device. So let's go to my laptop, and I have here AWS Web Console. As Tanmoy mentioned, we need to create a specific job where we can pick up that we plan to create an Amazon FreeRTOS OTA update job. Then we definitely need to have a device which we plan to update, and we'll update this device that I was using before to control the virtual 3D camera. And let's say the new firmware will have a new feature. Our client wants to reverse the control of the 3D camera. So when we click on the left, we'll move the camera to the right. Okay. So let's select this device. Here it is. It's our thing. We'll click next. Then we need to select a consigning profile. And actually we have already prepared one. This is like the part that signs the firmware that we have already placed to the S3 bucket. Let's select it. Here we need to identify the path name of the firmware image that is being run on the edge device, and we have the same as the name of our new firmware. So it's AWS demos ble.bin file. And we need to select the role that requires S3 to just get the access to this firmware. So clicking the next button, we need to specify an additional ID. It should be unique. For example, it will be Twitch session test final and maybe
it's a long ID.
it should be a unique. And then we will add, for example, that it's 16th of April today. Okay, let's put it so. Then we don't need to specify any tags for these purposes, and we'll create a job. Okay, I'm clicking on the create button, and the job is being created in AWS. So here we can see a notification that the job was created successfully. Let's view it. And currently it's in a queued status. What does it mean? So the job has been created and a specific message has been sent to a system topic in AWS IoT core, and our device is being subscribed to this topic and receives the metadata. When the metadata is being received, our device responds that it starts the progress. So let's update the page and we should see that our device should receive the message. So actually the overall OTA process takes a while.
Yeah,
so,
I think you talked about, and this is something that's really interesting because with OTA, how it works is that, as Andrew mentioned, you have this like request response that happens as well. But then there's also the opportunity, the device kind of picks the right opportunity to start the job, and then it might say, I've received it, but I've got some work to do before I start it. You know, I need to essentially maybe reprioritize task, I need to clear some space, and then when I click start, it changes to an in progress. And earlier, Andrew, you talked about a couple other points that I wanted to bring up that I think is really interesting is there's kind of two levels of security that are part of that workflow. You mentioned the code signing piece.
Yep.
But that last very step, you also had this individual role. And that role said, can AWS IoT device management actually go read this information from S3? So you can kind of think the conversation I have with customers on security, like this separation of essential responsibilities. You know, we have one on the device that says, do I trust this firmware? And then also the customer gets the ease of mind where it says, also I want to make sure that I actually allow AWS IoT to get this specific binary. Maybe, you know, I want to create one for dev, test, prod so that if someone selects the wrong IAM role, they don't pull the dev build, because that would be really bad. They can only pull the prod build. So.
Right. And while we're in progress here, one other, I would say, good practice to follow is when you want to update your devices, don't update them all at once. Break them into different groups, for example, geographical group, or by version of the hardware, or by installation place. Update group by group, go step by step. You never know what could happen, God forbid, but it's better to break, God forbid, a small group of devices rather than your entire device park.
I just want an easy button. I want to be like, okay, you're exactly right. It's something where even with device management, you can roll out your updates over time. So like same best practice to give to our customers.
Okay, so the process is in progress, and I just want to point out that the device has already received a new firmware over the air, and currently we have a LED blinking. It tells us that on this specific device, it tells us that the update procedure is in process, and we have this OTA agent in place that just reboots after all these steps it did to the bootloader, and bootloader boots the new firmware from another bank and verifies whether it's valid, whether it's working, and it makes self tests that have been created before by the developers. And everything, if everything is okay, it just reboots once again to the new firmware that lies on the bank, and it just flushes the previous one.
And then also it then reconnects, reestablishes the BLE as well
Yes.
back to the router.
And we can see on my laptop that it has successfully finished the whole procedure. So let's test. Okay, I will open also this 3D panorama, and I will click on the left button, and it should bring us to the right. Yep, here it is. And I will click this button that is the right button, and it brings us to the left. So it's kind of, we were working like this, and now we just can reverse and click on the left, click on the right, so whatever.
Right, so even just that demonstration, we get an idea of how you can use Amazon FreeRTOS, all the drivers that are there, and then Klika, you've had experience then being able to take those and, let's say, modify to either run them in different protocols or even just like change the process of when a bootloader runs. We need to do these other validations versus something else. So this gives you this kind of best practices built in, but then the ability to kind of customize based on those interfaces what you want to do.
Right, you can think of it as changing device personality. So as of this time, you have one personality. After the update, you have a different personality. So it opens up a lot of possibilities, having one device, one hardware device already in place, but having virtually unlimited functionality, being able to deliver it to that device and then execute that functionality based on so many different rules.
Interesting. And even just to pivot on that personality piece a little bit, you can have personality be kind of a changing of the firmware over time. I'm also sure you're probably having customers that have personality meaning a completely different type of device. So we've been doing some of the short range implementations and over BLE, but you probably have use cases where customers are asking you, I need something that's much longer. I need to implement something that allows me to get to agriculture and, remote watering systems. So how are you having those discussions when the personality is a completely different protocol and kind of communication and connectivity question?
Right, thank you. If the device would have multiple connectivity options built in, as Andrew just demonstrated, we can have the short range communication in effect. But a lot of clients right now ask us about much longer ranges for different use cases. And a lot of people talk about narrowband IoT and express interest in narrowband IoT as a part of being very rapidly rolled out 5G. Right now, kind of the race is on around the world, and more regions are being opened up with effective narrowband IoT networks. So delivering the connectivity over much longer ranges with narrowband IoT enables precision connected agriculture, for example, or tracking of assets which would not be previously possible, or tracking of smart mobility objects, tracking drones, long-range drones, or moving vehicles. So it definitely opens up more and more use cases in different industries.
Oh, interesting. I know, Tanmoy, we had customers at reInvent. We talked about all those implementations you could have for Amazon FreeRTOS and customizations, but you're probably also seeing customers who are saying, I don't have Wi-Fi relay, I've got something else, and then helping them figure out how to implement that in Amazon FreeRTOS.
Yes, absolutely. So as we have seen in the block diagram, Amazon FreeRTOS is completely modular. So we are defining abstractions and management libraries that are modular and interface directly with the drivers and the networking stack that the microcontroller vendors provide. So even with cellular connectivity, for example, that we don't have an abstraction for at this point of time, customers can actually look at and import directly to the networking interface that the cellular vendors provide. So you can think of the hardware, popular cellular hardware, the drivers that it provides. We can interface directly to those ports, and Amazon FreeRTOS, all the features that it provides, whether it's over-the-air updates or using a different connectivity or using MQTT, TLS, TCP, it all works seamlessly, properly. So you don't have to wait for the abstraction layer to be there to actually work with Amazon FreeRTOS and your board that you're working on. That's the advantage of having an open source, free that you can tweak the source code and do your own implementation.
Yeah, and I know, Andrew, you've actually done some tweaking of the source code as well for narrowband IoT and long range. So now we've got another really, really cool demo to show how, taking, again, the art of the possible and making it super tangible.
Yeah. So let me please demonstrate it. Here we have another demo that has several development boards. So don't look at the form factor. So in the production, in the real device, it's definitely a small device and the form factor is different. So what we have here, we have an NXP board. It's like an NXP Freedom board that runs Amazon FreeRTOS. To this board, here it is in the bottom, we connect an extension shield from STMicro with environmental sensors. And data from these sensors goes for processing to this NXP board that runs Amazon FreeRTOS. Then we create with the Amazon FreeRTOS libraries MQTT packets. We also encrypt the data and then use narrowband IoT modem as a bridge and as a connector to the cloud. And the data is being sent to the cloud, processed, and visualized at the dashboard. So it's a small demonstration of possibilities of narrowband IoT with Amazon FreeRTOS.
And Andrew, what powers the narrowband IoT? What MCU and module do we have there?
So we have QuickTel BG96 here, and this module has inside Cortex A7, if I'm not mistaken, MCU that's also powerful enough, and it does all the job with the connectivity and sending the data over narrowband IoT.
Thank you.
And yes, here as narrowband IoT is energy efficient technology, we connected a power bank that just brings the power to all the development boards. So if we move to my laptop, we can see that we have a graph here that shows the environment around us. So we have here a temperature, and it's approximately 25, I would say, degrees above zero in Celsius. And we have humidity that is approximately 36 percent. And I would like to demonstrate that it's almost like, I would say, not real time because it's narrowband IoT and cost and energy efficient technology. We can tweak the graph by holding the temperature sensor. Tenmoy, don't you mind?
The lovely assistants going to raise the temperature.
So in a few seconds, we'll see that there should be a spike in the temperature. And also we should see that humidity is changing here. So just a second. And here we see a small spike that should go higher.
Tamoy is just so cool. He's like so cool under pressure. It's like steady hands.
Okay.
I'm surprised temperature doesn't go down.
But I'll show then that we have a spike in humidity. Okay, so it's for now 48%.
Yeah, we can see.
Temperature sensor.
Just a
increase.
little bit of time. Just a little time to let it simmer. Cool. And then I saw some questions in the chat as well.
Thank
in
you,
terms
Tamoy.
of languages and whether you should use C, C++, Python, Java. Just kind of interesting, Andrew, Gennady, if you can talk about what languages you see with your customers when you're implementing, seeing primarily C with Amazon FreeRTOS, you seeing people asking for C++ or Python, or what are you seeing in the field?
So actually it depends on the specific use case that we solve and on the device that runs either Amazon FreeRTOS, either Amazon Greengrass. So for the edge devices, we prefer C because actually the FreeRTOS kernel is written in C, and we have all this compatibility within the libraries and on the compiling and the linking stage. So C is the primary language we use on the edge devices. And for the Lambda functions that run inside of the Greengrass, actually it depends on the device that runs Greengrass, whether it's powerful enough or not. But you can use any languages of your preferences. So we are not limited in the like hardware limitations, and so you can use the one you prefer.
And we see a lot of Java. We see
Yes.
some Node, I believe.
Node from fast prototyping and for just catching the events and then processing them. But like enterprise more tend to use Java in this.
Yeah,
Edge
I
devices.
came from an enterprise space, so I like use Java. Like, I mean, it's been forever. People were just like, "Why are you waiting to compile?" I'm like, get my coffee, or check the news. But then it's kind of C's. You go to the edge of the edge. Amazon FreeRTOS. You're using C. You want to be as efficient as possible. You want control over your RAM and memory. You want to essentially be able to tap into all the levers that you can, especially when you're in a constraint. Again, the edge of the edge. And then depending on the environment you're in, when you get into the edge space with things like Greengrass and Lambda functions, you then get to pick the ones that are most kind of you're used to, right? So if you're used to Node or Python, you can bring those in Greengrass and then make use of maybe something that your cloud or enterprise developers are more used to.
Right, right. I mean, especially on the edge of the edge, when you talk about battery operated devices, that's where efficiency and power efficient of Amazon FreeRTOS come in. And from the Greengrass to the cloud, that's where you pick the compatibility. So you can write once and run, as you said, that Lambda, run it on the cloud or migrate it down to Greengrass device.
Yeah, I actually see some funny things on the chat about segmentation faults in C and like, things like that. So we won't say it wasn't, easy, but I think the trade-offs again that you get when you're trying to be as efficient as possible is super helpful. If I gotta malloc my own memory again, I might lose my mind.
More great here.
Andrew, I know we kind of went through the overall demo, but if you wanted to recap, I'll show on my laptop the actual end-to-end application that you built so people can see it. But you essentially had my.
Maybe you can tilt the board a little bit so we can show it.
I'll take this to.
Yeah, thank you.
My window doesn't want to agree with me. It wants to keep moving. So just so you can see the architecture components that you have here, you can kind of speak to them. So you mentioned before you have the QuickTel BG96 driver.
Yes. So this big board, this part, it's a BG96 development kit, and inside it has this BG96 module to connect over narrowband IoT technology. So we just use it as a bridge, and we send the data over UART, and the data is being processed in the main core of Cortex-M4 that is inside NXP Freedom board. Then it runs Amazon FreeRTOS, and Amazon FreeRTOS does all the job for encrypting the data, for then creating MQTT packages and just sending this information through a BG96 driver and modem to the cloud. And we also have here ST micro extension board with different environmental sensors that we just take the data and send to the cloud.
Awesome. So I know we've like dove into several different use cases. We kind of got a great glance of Amazon FreeRTOS at a high level and how customers are using it and the extensibility of it. And then it was awesome to have Klika here because you can dive into what you're seeing from your use cases for OTA, short range implementations, and long range implementations. I would love to kind of wrap up by getting a sense, especially on the Klika side, if you had to give our audience, one thing to take away, one place to start building their IoT applications, what would you recommend to them?
I'll start and then I'll pass to Andrew. I would say pick a reputable, really well described development board, such as boards from ST Microelectronics or Nordic or NXP. If we talk about narrowband IoT, again, NRF91 from Nordic, and of course BG96 from Quectal, use the same hardware which you're going to use in production. It will save you a lot of time, it will save you a lot of tears, because you don't have to migrate between different hardware versions, and you can take it from prototype to production much easier. What do you think?
I totally agree, Gennady, with you. And the only thing I would like to add is not to be afraid of the pitfalls. When you work in a constrained environment, you always face different issues. They can be software issues, hardware issues. You need to work with the memory, you need to work with the CPU. So if you come from the cloud perspective, so don't be afraid, just experiment and try to work with the embedded. And a bit later, you'll see the results and successfully connected devices to the cloud.
Awesome. And then Tamar, I'd love to hear, we talked about all the features of Amazon FreeRTOS and all the capabilities customers and partners have. What would you say is your takeaway for our audience, things they can try out after Twitch?
The customers and partners that I talk to really love the fact that we are innovating really quickly and we're having a continuous innovation. And that enables customers to focus on their business logic, as we reiterated before, business logic and the application code, rather than doing the undifferentiated underlying work of porting to the different interfaces, connectivity, security, and developing their own OTA framework, for example. This has been and will be our philosophy. And together with all our semiconductor partners and technology partners, we'll strive to provide solutions that will make customers innovate more, create new and innovative IoT applications.
Awesome. So, we covered a lot this hour. So we dove into, again, everything from short range, how to customize Greengrass, how to customize the BLE beta branch. Then we went into long range, and then hopefully you got a lot of great best practices around OTA and security and kind of how to get started with some of the development boards that you see today. So hopefully you got a lot out of IoT, all the things, and we can't wait to do another episode with you. So thank you so much, and thanks Tanmoy, Gennady, and Andrew for joining.